What we're going to do in this section is approximate and find the exact values, if possible, of some square roots. Now, what is a square root? Let's look up here. Remember, a square root is some number under this symbol, which we call the radical sign, in which we're looking for a number times itself that gives us that product. If you know your multiplication facts, it will help greatly in this section. So what number times itself gives us 64? Well, hopefully you know that 8 times 8 is 64, or we can rewrite that as 8 squared. Since 8 times 8 is 64, or the square root of 64 is 8 squared, we say that the square root of 64 is simply equal to 8. So we'll erase this and just say the square root of 64 is equal to 8. Again, when working with square roots, you're looking for some number times itself that equals a number under the radical sign. So again, the square root of 64 is simply equal to 8 because 8 times 8 is equal to 64. Let's try another one. Oh, before we do, by the way, you might say to yourself, wait a minute, I know another number that has a product of positive 64. That's negative 8 times negative 8. Well, you're right if you thought that, because that's true. Negative 8 times negative 8 is also positive 64. But by definition of square roots, we're going to make sure that the number that we're looking at for the square root is always a positive number. We call this the positive square root. Let's look at our second example. We have the opposite of the square root of 121. Now, don't be fooled by that negative sign. All that means is the negative sign is outside the square root symbol. Ask yourself this question: what number times itself equals 121? Hopefully you've come up with the number 11, because 11 times 11 is 121. So we simply say then that the square root of, or the opposite of the square root of 121 is simply negative 11. Let's move on to some fractions. Just because they're fractions doesn't make it that much more difficult when finding square roots. We ask ourselves, what number times itself gives us 9/25? Well, we know that 3 times 3 is 9. We also know that 5 times 5 is 25. So the fraction 3/5 times itself, 3/5, gives us this product 9/25. So because of that relationship, we'll say that the square root of 9/25 is simply 3/5. Let's try one more of those fractions. Again, just because this one minus the square root of 121 over 169 has a negative out front, it doesn't change our calculations one bit. All we're going to do is leave that negative out front and ask ourselves the same question. What number times itself is 121? Well, we just found that, 11. The second question we ask ourselves is what number times itself is 169? It may take a little bit of calculation on your part, but actually 13 times 13 is 169. So we'll write it here. As you begin your work with square roots, it might be helpful for you to perhaps keep just a little list of square roots to reference until you get used to working with square roots. For example, you might just write here a list of perfect squares for yourself, just to reference as you begin your work with square roots. And as you work, you'll see that you get to learn them a little more. For example, you could write 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, and 10 squared is 100. Now you could go higher. I usually advise my students to keep a list up to about the number 15, because those are the numbers you'll probably utilize in your work with the square root chapter. If you keep this as a reference, then when you see these numbers 4, 9, 16, 25, etc., come up under the radical sign, you'll know that it's a perfect square and it simplifies just like this. So keep that in mind as you begin your work with square roots. Now, let's look at some different kinds of square roots. Let's see how things change when we have the square root of decimals. Let's look at the following problem. Let's look at the opposite of the square root of, oops, I forgot the 0. Let's keep this as 0.0036. Now, at first when you see that, you may be a little bit confused because of the decimal point under the radical sign, but it doesn't change much. We see there we have the number 36. Looking at our list of perfect squares, we see that 36 is 6 squared, or 6 times 6. So we know that if it was just the square root of 36, our answer would be 6. But the only difference is we have 0.0036. So still, when we simplify, now don't forget this minus sign just comes right down. We know we're going to have a 6 as a part of our answer. But because of our work with decimals, we know that if we want 1, 2, 3, 4 decimal places, we're going to multiply 0.06 times 0.06. That'll give me the 4 decimal places, and that's what the square root of negative 0.0036 is, simply negative 0.06. If you want, check it on your calculator or do it by hand. You'll see that it works. Now, let's try a larger number. Let's look at the square root of, let's say, 2,500. Now again, because we have our list of perfect squares handy, we see that 25 here is 5 squared. In other words, if we are just asked to find the square root of 25, we would simply say 5. But because we have 2,500, we've got a couple of zeros to contend with. So what number times itself is equal to 2,500? Well, since I have 2 zeros and I know that I multiply 50 times itself, that's going to give me 4 positions. I know that the square root of 2,500 is simply 50, because 50 times 50 is 2,500. You'll get used to this as you work more and more with these square roots. Now finally, what happens if the number under the radical sign is not one of our perfect squares? What are we going to do? Well, let's look at an example. This time, let's approximate by using a little common sense, and after we do, we'll use our calculators to check. What if I asked you to find the square root of 3? You check your list, you notice that 3 is not a perfect square. Now we can approximate this using the following method. How do I get a feel for what the size of the square root of 3 is? Well, I do know that the number 3 is between a couple of square roots. 3 is less than the square root of 4, and it's bigger than the square root of 1. Let me show you. I had the square root of 1, which I know is less than the square root of 3, which I know is less than the square root of 4. Obvious, because 4 is bigger than 3 and 1 is less than 3. Now, why did I choose these numbers in particular? Because these happen to be perfect squares. I know that the square root of 1 is 1, because that's 1 times 1. I know that the square root of 4 is 2, because that's 2 times 2. That's from my list here. And so that tells me that the square root of 3 is somewhere between 1 and 2. How do I get that exact value? Well, that's impossible to do by hand here. So at this point, this just gives us a feel. We can also make the following conclusion. Since 3 is a bit closer to 4 than it is to 1, we can say that the square root of 3 is more than 1.5. I would peg it at about 1.6 or perhaps 1.7. If you want to find the exact value, what you do is take your calculator, hit the square root button, enter the number 3, enter equals, and you will get about 1.732. So that's approximately what the square root of 3 is equal to. Let's just try one more of these. Don't you think they're kind of fun? Again, we're approximating the value of the square root. We want to know approximately how large is the square root of 35. Now again, 35 is not a number on our list. It's not a perfect square. But two numbers above and below 35 would be 36 and 25, both perfect squares. So I'm going to say that the square root of 35 is bigger than the square root of 25, and it's less than the square root of 36. Why did I put that between those two numbers? Because the square root of 25 I know is 5, and the square root of 36 I know is 6. Now, again, because 35 is much closer to 36 than it is to 25, in fact, it's almost 36, that tells me that the square root of 35 is someplace between 5 and 6, but much closer to 6. We might make an educational guess, 5.9. In fact, if you wanted to find a better or a closer answer, use your calculator to get 5.916. Now again, let me emphasize one thing. I don't want you to think that when you use your calculator, this is the exact value of the square root of 35, because that is not true. Square roots that are not perfect squares, as in this case, do not have exact values. Remember, these are irrational numbers. What that means is they're equivalent to a decimal that never terminates and never repeats. So this 5.916 is actually an approximation to the value of the square root of 35. But for our purposes, it's close enough when we make our calculations. So try some of these square roots on your own, keep the list handy, and have a great time.